In this video, we'll have a look at how we can test the validity of statements in Matlab in a completely logical and systematic manner by using Boolean algebra. In Boolean algebra, each variable can only take one of two independent values, which represent true and false. In most computing languages, including Matlab, these values are denoted by 1 and 0. Although in Matlab we can also type true to get 1 and false to get 0. Matlab knows that these are logical values to be distinguished from ordinary numerical values. If I click on ANS in the workspace, we can see that Matlab has identified that this is a logical value, whilst if I just type the number 0 by itself, it's an object of different type. We'll look at the different types of objects that we can define in a later video, but for now it's enough just to recognise that logical values are different to ordinary numerical values and that they can be used in different ways. I'll give an example in which we use logical operations to select elements from arrays according to some criterion. I'll create an array of random integers which I'll call v in the range from 0 to 20. And this array is going to have 10 rows and 5 columns. I can use the less than operator to determine which values are less than 10. This returns a logical array of 1s and 0s. We can see from the array that the element in the first row and first column of v was not less than 10, but that the element in the third row and third column was less than 10. This expression is going to get us all elements from v which are less than 10. We used a strict inequality here, but we could also implement a non-strict inequality. We can use less than or equals, or we can use greater than or equals. I'll select all values which are either greater than or equal to 15 now. Typing greater than or equal to like this is equivalent to using the greater than or equal to function, GE. So we can type GEV15 to get the array of 0s and 1s representing values from v that are greater than or equal to 15. And then we can select them using logical indexing, just as we did above. Less than equals is the LE function. A strict inequality less than is the LT function, which stands for less than, and a strict greater than equality is the GT function. We can find out how many values were bigger than 15 in the array above by just typing length. Now, let's naively try to count how many values in the array are exactly equal to 15. I can see that there are a few. I'll put v equals 15. Whoops, it didn't do what I was hoping for. Recall that in Matlab the equals symbol is used to define a variable by assigning a known value on the right to a variable name on the left. So we need another operator to test equality. We use a double equals sign together. I'll go back and I'll make another random array of integers so that we can test it. Now, let's try again to test which values are equal to 15. We can type v equals 15. Or we can type eq v15 to get the same result. To count how many values were equal to 15, we can either do length of v equals 15, or we could use Matlab to add up the ones. We can use sum v equals 15. The reason we need to use sum twice there is that this function adds up the numbers going down the columns. So sum v equals 15 will give us the totals going down the columns. The find function can also be useful. It returns the indices of elements in the arrays which satisfy the given conditions. So find v equals 15 gives us these two results, which tells us that v of 30 is equal to 15 and v of 31 is equal to 15. To test which values in v are not equal to 15, we can use the not equals operator. Alternatively, we could use the not operator together with the equality operator. Not gives the logical negation of the results in the array. In some circumstances, we may wish to test whether two arrays are exactly the same. For instance, if I put A equals to 1, 2, 3, minus 1, and then I put B equals A, so that these two arrays are the same. If I type A equals B, the result shows me that all of the elements are the same, but what I really want here is to simply return the result true to confirm that the arrays are identical. I can do this by using the isEqual function. IsEqual AB returns the result logical 1, i.e. true. Now let's look at ways of combining logical results using AND and OR. Suppose, for instance, that we wish to test which values in the array V are between 3 and 5. We can test which values are greater than or equal to 3, which gives an array, and we can test which values are less than or equal to 5, which gives an array. And then we can combine them using V greater than equals 3 and V less than equals 5 to find the values which satisfy both conditions. We can select them from the array as before using the logical indexing method. Or we could find which positions that they were in by using the find function. To select values which are outside the range, that is ones which are not between 3 and 5, we can use the not function. Or we could achieve the same result by using the logical OR operator. We can type v less than 3 or v is bigger than 5. Notice the symbol that's used here to represent the OR function. We can also use the OR function like this. It's worth mentioning that the logical OR operator includes the possibility that both conditions are true. Typing OR FG, where F and G are statements, allows for the possibilities that only F is true, or only G is true, or that both F and G are true. In the example here, it's impossible that both conditions were true, because a number can't be less than 3 and bigger than 5. But if I put something like v is less than 3 or v cubed is greater than 5, using the element-wise power operator, then the number 1 satisfies just the first condition, so it would be selected, whilst the number 3 satisfies just the second condition, so it would be selected, and the number 2, which satisfies both conditions, would also be selected. If you want to exclude values satisfying both conditions, then you can use the exclusive OR operator, which is called XOR. These types of logical operations are also discussed in terms of the set union, set intersection, and complement in my videos about set theory. To finish off, let me briefly mention the short circuit operators, which are and, or. These are used for cases where the outcomes being combined are scalar logical values, that is, a single true or false value, rather than an array as we had in the examples here. For example, suppose that I want to see if a single number x is between 3 and 5. I can test x less than equal 3 and x greater than equal 5. But notice that since the first condition fails, there's no point in testing the second condition. Normally, Matlab evaluates the two statements first and then combines them. If we use the short circuit AND operator, then the second condition is evaluated only if needed. Similarly, the short circuit OR operator only evaluates the second statement in cases where the first statement is false. The short circuit operators cannot be used when the statements being combined give logical arrays. So I can't use these statements with the arrays A and B, for example. If you want to read more about logical relations and ways of combining them in Matlab, you could have a look at the Matlab help guide on operators and elementary operations, especially this bit here about relational operations.